Okay, so number theory is everywhere, and it's even been in the movies, and so GCD, Bezout, all this stuff, and I'm going to give you an example of that. Die Hard 3. I think it's Die Hard with a Vengeance, where the bad guy is Simon Gruber, and then the good guys are, John McClane and Zeus Carver, and Gruber gives them a puzzle. Okay, here's the puzzle. You have a 3-gallon jug and a 5-gallon jug. And an unlimited supply of water. And you have to somehow measure exactly 4 gallons and put it on a scale. The scale sees that it's exactly 4 gallons and turns off a bomb. Otherwise, bomb explodes, body parts flying everywhere, all that good stuff, movie ends, and so on and so forth. Okay? So, and they did some this and that, and who knows, nobody can understand what they did when you watch the movie. But, okay, let me give you a sort of a strategy for this problem, this kind of a problem. So, step 1, repeatedly fill the 3-gallon jug. Okay, that's easy to do. You repeatedly fill the 3-gallon jug. Okay, but now here's what you do with the water as you fill each time you fill it. So, you have to then empty the 3-gallon jug. So, empty the 3-gallon jug into 5-gallon. Okay, as much as you can empty, and then, you have to pour the stuff out of the 5-gallon jug. So, as much as you can, okay, and then empty the 5-gallon jug if it gets full, empty the 5-gallon if it gets full, okay, and then continue to empty the 3-gallon jug, and continue to empty the 3-gallon. Okay, so that's the basic idea. So, let me show you how this would work in this example. So I'm going to represent the number of gallons in the 3-gallon and the 5-gallon by a pair of numbers. So the initial state is 0, 0, 0, 0. Okay. Now what this says is, fill the 3-gallon jug. So if you follow rule 1, it takes you to the state 3, 0, which means 3 gallons in the 3-gallon, that's full, and 0 here. And then that takes you to the next step, which is to empty the 3-gallon. Okay, so you empty the 3-gallon, and that gets you to 0, 3. Okay, and now repeatedly fill, so you go back here. So fill it again. Okay, so you get to the state 3, 3. Okay, now you need to try to empty, but now when you try to empty, this thing gets full. Okay, so this thing gets full when you try to empty it. Gets full with 1 left in here and 5 here. But when it gets full, you throw whatever's in the 5-gallon out. So you throw it out, you get to 1, 0. And now you continue to empty your 3-gallon jug. So that gets you to 0, 1. Okay, so this is all step 2 in some sense. Okay, and now you repeatedly continue. You fill. So that takes you to 3, 1. And you can see what's happening next. Look! When you empty the 3 into the 1, you get 1, 4. Wow! Bam! Look at that. Beautiful. Okay, so this is step 2. Okay, and you've solved the problem. Okay, now I don't know what they did in the movie. I'm pretty sure they didn't do this. They jumped around like this, and all of a sudden, by magic, they got 4 gallons. Okay, so where's the number theory? Where's the GCD? Where's Bezout? Okay, let me show you. Okay, so, in this process, imagine that you have emptied the 3-gallon jug X times. You emptied the 3-gallon X times. And what's going on? You're emptying. As you empty, whenever it gets full in the 5-gallon jug, you throw that out. So that means that you might have had to throw out of the 5-gallon jug, Y times. So which might required, emptying the 5-gallon Y times. Okay, good. Okay, so how much water is left in the 5-gallon jug? How much water is left? So let's call that L, left water. In the water left in the 5-gallon jug is how much you poured in, which is 3 times X, minus how much you sent out, 5 times Y. Okay, good. But wait, you look at this and say, well, wait a minute, you've got 3 and 5, and this is an integer linear combination of 3 and 5. And didn't we learn about that with GCD and Bezout? Yes, we did. So let's compute the GCD of 3 and 5. GCD of 3 and 5 is equal to 1. Okay? And we know that that's an integer linear combination of 3 and 5. And indeed, look, 1 is equal to 2 times 3 minus 5 times 1 minus 1 times 5. Oh, sorry, let's write it this way. 3 times 2 minus 5 times 1. And this, in this example, exactly corresponds to emptying the 3-gallon jug twice. Okay, so emptying twice the 3-gallon jug. 3 gal emptied twice. And the 5-gallon has to be emptied once. 5 gal emptied once. Okay, and indeed, if you do that, you should have the GCD of 3 and 5 in there, okay, which is 1. And let's see. When you have emptied the 3-gallon into the, when you've emptied it, so here you've emptied it once, then you fill it, you emptied it again, and you end up here. Okay. So this corresponds to that state. So this state corresponds to this equation. Now I want 4 gallons. So look, if I just do this 4 times, I should have 4 times as much in my 5-gallon jug. So multiply by 4, I get 4 is equal to 3 times 8 minus 5 times 4. There's a hardcore solution that we know must exist. In other words, what the GCD and Bezout says is that if you have emptied the 3-gallon jug 8 times and the 5-gallon jug 4 times, you will indeed have 4 gallons there. And let's see, 3 times 8, well, we all know what that is, 24, and 5 times 4 is 20. Yes, indeed. Okay, so you have to empty the 3-gallon jug 8 times, and in the process, you will empty the 5-gallon jug 4 times. So it means that this guarantees, this is a strategy to guarantee getting the 4 gallons. Bezout and GCD, it turns out that we got there earlier, okay, but that need not have been the case. Now, okay, what we see here is that whatever the GCD is, you can get a multiple of the GCD in the 5-gallon jug and nothing more. No other numbers are possible because whatever you get in there is a linear combination of 3 and 5. So it has to be a multiple of the GCD, and luckily the GCD is 1. So, try this problem instead with a 3-gallon and a 6-gallon jug. Looks like, oh, it should be easier. You've got a bigger jug here you can mess around with. Try it. Try it. You can't do it. You can't do it. And if you want to, and okay, so one quick idea for why you can't do it is that, anything that's left in the 6-gallon jug will never be 4. Okay, because it has to be a multiple of the GCD, which is 3. And 4 is not a multiple of the GCD. And so try to see if you can actually solve this problem, 3 and 6-gallon jugs. So if the movie producers had made a mistake, because if they didn't understand number theory, and, they had used 3 and 6-gallon jugs, bam! No way to do it, boom! Bomb explodes, no more sequels. Okay. All right. So let's erase, and then I'm going to come back and show you the proof of the fundamental theorem of arithmetic part 2.